In this lesson, we'll be talking about rational and absolute value equations. So anytime we have a rational equation, what we're going to do is we're going to start out by factoring. Factor it as much as you can. Sometimes factoring it even causes things to cancel out before you even have to work. Once we factor, we find a common denominator, we multiply both sides by that, and we get a value. The one thing about these is once you have an answer, you need to make sure that that wasn't a value that gave you a 0 in the denominator before. If it does, you call it extraneous and throw it out. Let's do this first example. Remember, the first step is always factor everything that you can. So in my first example, the left side doesn't have anything that can factor, but the right side does. This is x minus 1 times x minus 3. Hey, we're in luck. These factors are the same as the things on the left side. If we were to calculate that LCM, the LCM would be x minus 1 times x minus 3. Let's multiply both sides, which means all the terms, by this expression. Make sure that you do this to every single term, and then you can go back and look at what cancels. The x minus 1's cancel, the x minus 3's cancel, and both cancel on the right side. This leaves us with x times x minus 3 plus 2 times x minus 1 equals just negative 2. Now we'll do x squared minus 3x by distributing the x. We'll distribute the 2 to get 2x minus 2. I'm going to add 2 to both sides, and that cancels it out on both of them. I get x squared, combining these is just minus x equals 0. So I factor out an x. This gives me x equals 0 or x equals 1. So check it out. Does x equals 0 give me any problems with zeros in the denominator? Nah. X equals 1? There it is again. If I had used x equals 1, I would have gotten a 0 in the denominator. So that makes this extraneous, which means our only solution to this equation is x equals 0. So this one is for you to try, so feel free to pause the video and see if you can get this one. Okay, I hope this one went okay for you. Let's go over it and see if it made any sense. So again, the very first step is x over x minus 2 plus 1 over x minus 4. None of that factors. And all we need to do is factor the right side. And so that comes out to look just like this. X minus 2 times x minus 4. Again, our LCM is nice and easy. It's just the x minus 2 times x minus 4. The terms show up only once, or to the 1 power in each of these, and those are the only two terms. So I'm going to multiply both sides by x minus 2 times x minus 4. And then we can start canceling things. There's some cancellation. There's some cancellation. And on the right side, all of them cancel. So I'm left with x times x minus 4 plus 1 times x minus 2 equals just 2 this time. Distributing my x, I get x squared minus 4x. And distributing a 1, or really just ignoring it entirely, I get x minus 2. So I'll subtract 2 from both sides. This gives me x squared. I get a minus 3x, and negative 2 minus 2 is minus 4. Let's factor it. X minus 4 times x plus 1. So this means x equals 4, or x equals negative 1. Now, check it. X equals 4. Yeah, that would definitely give us a 0 in the denominator, right there. So we got to throw that one out. That's extraneous. And how about negative 1? Negative 1, yeah, that one's okay. That won't give us a 0 in the denominator. So there's our answer, just x equals negative 1. Let's move on to absolute value equations. In order to solve these, it's very important that you learn the rule. You get the absolute value by itself first, and then you split it into two equations. You must do this step or you will get the problem wrong. Split it into two equations. The first equation, you just drop the absolute value. The second equation, you again drop the absolute value, but make the number on the right negative. So we get two equations. 3x minus 2 equals positive 5, or 3x minus 2 equals negative 5. So pay attention to those rules. You have to follow these rules for this to work out. Positive and negative for the two equations. So if I add 2 to both sides, I get 3x equals 7. And over here, I get 3x equals negative 3. If I divide by 3, I get x equals 7/3 as one solution. And the other one, I get x equals negative 1. Both of these values solve the equation. And if you didn't use the rule carefully and split it into two equations, you might not get both equations. That's very important. Next example. The absolute value is not by itself. So what we need to do is subtract 6 from both sides first to get the absolute value by itself. Something is strange here. Normally it starts out positive and I say, well, let me do the positive one and the negative one. If you try to be too hasty on using the rules, you might mess this one up. So tell me, when you take the absolute value of a number, what does the answer come out as? Isn't it always positive? How could I possibly take an absolute value and get negative 4? So let me just mention, this is always positive. You can't possibly plug in any value of x and get negative 4. No solution. There is no way to plug in something that does that. Let me make sure that this rule is clear. This c here, you'll notice it's a positive number. You solve both equations, but only if it's a positive number. If it's negative, it's automatically no solution. What if it's 0? Now there's nothing wrong with this one. All you'd have to do is say, well, it could be 6x minus 2 equals 0, or 6x minus 2 equals negative 0. But that's not any different, is it? Negative 0 and 0 are really the same thing, so if it just happens to be 0, there's only one equation. So 6x equals 2 when I add 2 to both sides, and dividing by 6 I get x equals 1/3. It makes perfect sense that at times these will come out so that if it's 0 on one side, you just get one equation. This last one's for you to try. Feel free to pause the video and give it a try and see how that goes. Okay, let's see how you did. I'll follow some of the steps, and if you ever feel like you can finish it and you weren't able to finish it before, feel free to pause the video again and finish my steps. First step is to add 9 to both sides. I get the absolute value of negative 8x plus 2 equals 14. Now you might be looking at this negative sign right here and wondering, how does that come into play? It's okay, we're just going to use the same rule as we did before and not try to overanalyze this negative sign. We've got an absolute value equal to a positive number. That's good. That's exactly what we want. So I'm going to split it into two equations. I'll drop the absolute value. One of them's positive, and then the other one is negative. The equation is equal to 14, or it could be negative 14. Let's continue. If I subtract 2 from both sides, I get 12 over here, and I get negative 16 over here. If I divide by negative 8, I get 12 over 8 reduces to 3/2, and it's negative. And over here, if I divide by negative 8, I get 2.